Hi, everyone. All right, let's get started. I'm hoping you can all hear me all right. Okay. I would like to welcome you to the third GANS Geo Talk, our webinar series that we are putting on every second Thursday throughout the pandemic to try and bring people together to talk about like-minded topics while still isolating from a safe distance. Today's talk is from Simon Sankey, Engineering. He has the concept of BIM and all the emerging technology. He's been working with a lot of cool technology at the meeting today. So he's going to give us a talk on scan to BIM to AM at some point as well. Green, if he wishes. We'll stop sharing. And be sure to take yourself off mute as well, Simon. And for everyone else, if you could please keep yourselves on mute, as well as keep your videos off, because as a reminder, this is being recorded. So you'll be able to find this on the Geomatics Association's YouTube channel once this is done, probably in about a week or so. If you have any questions, please type them in the chat or wait until the end so that we can try and mitigate any confusion over who's talking. All right, thank you very much, Simon.
Thank you, Candice. First of all, thank you for logging on to see this presentation. My name is Simon Sankey and I'm the BIM manager at EastPoint. My presentation is called Scan to BIM to AMS. BIM, AMS, we're going to hear a lot of acronyms today. As I'm not sure who my audience is, I'm not going to assume they're obvious to everyone. So to start with, BIM, Building Information Modeling, still in its embryonic stages here in Nova Scotia, but starting to make some real traction. BIM is not a software, rather a process which centralizes valuable data in a 3D model, allowing AEC professionals to provide efficiencies throughout the design process, the construction phase, and even beyond that into commissioning. Owners can realize even more value by maintaining a BIM model for AMS and FM purposes. AMS, Asset Management Solutions, and FM, Facility Management. I'm not going to talk too much about those last two today. My hope today is that you all learn about one of the many applications of BIM, more specifically as it relates to bridges. That being said, let's go to the first slide. We were presented with an opportunity to apply BIM in a unique fashion. Our task was to scan and create a BIM model of the McDonald Bridge, a real iconic part of the city, the link between the Halifax Peninsula and Dartmouth. Let's take the scan to begin with. There are several methods we could have used to achieve this: laser scanning, Pro Series survey style scanners. We even considered drone technology. All technologies I'm sure you in the world of geomatics are familiar with. After a successful trial run with our laser scanner, we felt confident we could capture the data required. This particular model has a speed of 2 million points per second and a resolution of 3 millimeters at a distance of 10 meters. Its speed, accuracy, portability, and ability to register the data in the field all lent itself to the task in hand. Whilst we were confident the data we captured would satisfy our clients' requirements, it was still not without its challenges. We estimated a number in the region of 600 plus scan setups would be required to capture the entire bridge. In order to capture clear data, we also needed the weather to cooperate. Not something we typically associate with Nova Scotia, but not too much of a challenge. We just pick our days. It's a consideration nonetheless. As you can see from at least two of the shots on the slide, confined spaces can prove another challenge. And if you've ever driven across a bridge, you've inevitably been caught in traffic, sat in your car, and felt the movement that can occur. The towers can sway anywhere up to 3 feet. It's designed to do that though, so don't panic. Fortunately, the VIS, or Visual Inertia System, a video enhanced inertial measuring system to track movement of the scanner position relative to the previous setup in real time, is a feature on this scanner model and is able to combat the vibrations and movement of this huge structure. When we have captured all this data using the scanner, what is it and what can we do with it? Well, first of all, a point cloud, a digital representation, a snapshot in time of an asset. This is a plan view of the complete point cloud to date. Here we have scanned all the ground areas around the Dartmouth side and most of the ground areas on the Halifax side of the bridge. We've also scanned all along the sidewalk. It's not really clear at this scale, admittedly. This shot shows the same plan view. The yellow triangles indicate each and every scan setup required to capture all this data. And all this data is not overselling the amount either. What you see here is 100+ gigabytes of data. Currently, we are focusing on the bike lane and the catwalk below the deck under the vehicular roadway. Point clouds. This is the primary reason to use a laser scanner. To capture existing conditions accurately and in a format that can be brought into a modeling environment to assist in model creation or model validation. The top right image is the point cloud. And if you zoom in on the image, you can see a measurement taken of the width of the sidewalk. The point cloud is made up of millions, even billions of points that are captured during the scanning process. High dynamic range imagery and thermographic readings can also be obtained. Once the captured scan data is registered and published to a point cloud, we can adjust the color intensity to best display the existing conditions. At the top right, we see the point cloud monochromatically in a grayscale intensity. This is often the best way to see areas in darker places. The hue intensity can also brighten areas with very little light, as you can see in the bottom left image. The shot on the bottom right is the point cloud and the high dynamic range imagery providing a realistic view of the scan data. These are features that become very useful when discerning components during the BIM modeling process. Again, a shot using the multi-hue rainbow mode of displaying the scan data can provide some great contrast for clarity and discerning the different elements within the point cloud. Here we see the same shot, but it's the point cloud image this time using the color taken from the HDR imagery. And finally, the same shot showing only the high dynamic range imagery. This can prove very useful as a reference. This fly-through of the point cloud will give a clearer picture of the point cloud as a whole. The red dot in the middle of the image is an indication of a scan setup location. As we go through the deck here, you can see some data. The rest will be published and stitched to the overall point cloud after we scan along the catwalk. The resolution is a little off here. I recorded this over VPN from my laptop at home, whilst the point cloud data resides on a server in our office in downtown Halifax. But you get the general idea, I'm sure. As we, yeah,
I'm not sure if it's just my screen, but I can't see that fly through. It could be just mine. Perhaps somebody else can chime in and see if they can see it. Dave?
I can see it on my screen.
Okay, it is just me. Sorry for the interruption, just wanted to make sure.
It's all dependent on bandwidth, I'm sure.
No, for sure. Thank you very much. Sorry, Simon, please continue.
No problem, Candice. Thanks for checking. So here we are, returned to the setup location and back to the HDR image. So the scan data is captured, registered, and published to a point cloud. What now? BIM, a 3D BIM model. We agreed to model the bridge to LOD 200. There's one of those acronyms again, LOD. LOD in the BIM world means level of development, and LOD 200 is schematic design. This means we would model all the major components and elements that make up the bridge as defined by our client, Halifax Harbour Bridges. Before we could get started with the model though, we first had to ensure that the model was in real world coordinates. This speaks to AMS, or asset management, or the asset management solution, sorry. Remember this, we'll touch upon it towards the end. The coordinate system used in Nova Scotia, as I'm sure you all know, is NAD 83. In order to start the BIM model prior to scanning, we used the original 1950s construction drawings, drawings from the third lane job, and shop drawings from the Big Lift project. These were provided as reference from HHB. Once we had started the scanning, we linked the point cloud into the modeling environment and validated the BIM model using the point cloud. Here's a few slides showing the screenshots from the modeling environment with the point cloud linked. Here's an aerial view of the approach to Dartmouth Main Tower. This is a little further along in the same area. And here's a closer look at the DCA foundation on the Dartmouth side. And here is D1, the first foundation in Dartmouth. You might be able to make out some of the modeling lines in there as well. This is a shot of the bridge BIM model to date. And as you can see, we have modeled all the concrete work, the majority of the steel, and a percentage of the deck and catwalk. The BIM model, upon completion, is going to be used for an AMS or asset management solution, as I mentioned earlier. The data contained within the BIM model is exported to an asset management database. So how do we take it to an AMS solution? The data contained within the BIM model is exported to an asset management database, as I said. The Halifax Harbour Bridges O&M, operations and maintenance crew, will survey the bridge or the asset, and using handheld tablets and field apps, can view the bridge using AR. Here we go again, another acronym, AR, augmented reality. This allows them to see the BIM model in the foreground and the actual bridge in the background. When noticing an issue, they can simply touch the bridge component in the model and enter some notes related to the issue. This is where the real-world coordinates play their role. The component in question can be identified by its location. Given the duplication of so many components on an asset like this, the tablets will then feed into the AMS, which in turn will provide inspection reports and work packs to address the issues that arise, thus completing PM, or preventative maintenance. The BIM model, if kept current, can be used by the owner to design and plan future construction projects, organize site laydown areas, and construction sequencing. The data is centralized, accessible, and of value to the client beyond the construction phase. Herein lies the value of BIM and one of its many applications. This is BIM as it relates to bridges. So building information modeling can be misleading. The principles can be applied to civil infrastructure too. Hassan Chowdhury, the chief engineer at HHB, coined this process with another great acronym, BIMMS, Bridge, Information Modeling and Management Systems. I hope I presented something of interest to you today. My challenge to the Geomatics group is to find a way of leveraging today's technologies, whether it be scanning or modeling, taking the principles of BIM, using that centralized data to create more efficiencies on your projects or workflows, and extending their life cycles for owners and clients in your world. Before signing off, I'd also like to take the opportunity to thank Andrew Chow, my dedicated scanning specialist, and Gordon Bootlier, my BIM modeling specialist. Truth is, I'm presenting this, but those guys do all the hard work. And that just leaves me to thank Candice, the president of the Geomatics Association of Nova Scotia, for allowing me to present today, and thank you all for attending.
Terrific. Thank you very much, Simon. That's really interesting. Okay, I will open it up for any questions that anyone might have. I guess you did a great job.
The audio's breaking up.
Overall, did it actually take, of course, how long did it actually take you in maybe man hours to collect all of that data?
At this point, we're probably about 60% of the way through it. I don't actually have a record of the time logged, unfortunately, Candice, but I can give you stats at the end of the project. How's that?
Sure, that sounds good. I guess another question is regarding drones. What were your main considerations when choosing a terrestrial scanner over drones, especially for some of the further reaches of the bridge?
Cost and expertise, to be honest. There's not many drone technologies being used aside from the sort of LiDAR stuff in this region. So really it was about the expertise that we had and whether we could use the technology that we already had in-house, which we did. And having done that trial run, as I said, and proving that we could capture the data with our technology, we were happy to stick with what we had.
Certainly. And I can imagine using a drone in such a heavily populated area would be difficult as well.
Yeah, I'm not sure that D&D would be too happy about you flying a drone around around all the military installations down there. The Navy, yeah.
Definitely. No, you'd need all kinds of extra certifications to be able to do it over the road and over the water and etc. Right. Anyone else have any questions? I just have one more, and it involves the augmented reality system that you were talking about at the end.
Yes.
What kind of software do you have to be able to merge that kind of data, to be able to put it into the augmented reality and view it? What do you use?
Well, that's the side of it which lies still with the client. But there is the BIM 360, the Autodesk product, has two products, Field and Glue, which allow you to do that. For example, if you're out on site and you've done all your form work for pouring foundations, something that's quite useful is that you could go out with your tablet, you could have the augmented reality with the foundation model on the iPad and the actual formwork in the background. You could check that formwork prior to pouring the foundation, thus eliminating a sort of potential costly construction error. So that typically is where I've seen it used in the past. This asset management solution that we're coming up with for the bridge is somewhat of a new concept.
Yeah, very neat. I see so many applications to this kind of workflow.
Yeah, that's something that I found too, Candice, that once we got the technology, the applications are exponential. The places you can go with this technology is numerous, and that goes for BIM too. You know, that's something I wanted to highlight today, that the BIM's not just about buildings. It's more about the principles of BIM and applying that to anything, to any.
Mm-hmm. Yeah, no, that's wonderful. Okay. All right. Are there any final questions before I switch over to my own presentation and sign everyone out?
Hi, hello, this is Kaya speaking. Hello, Simon.
Oh,
Hello.
hi, Kaya.
Hi. I just have a question. I'm just sort of wondering, how was your work impacted by this COVID? How did your company go about? What did you have to change, or were you able to work through it? And what are you seeing for the future? Are you how are you going about finding your talent when you're hiring? So, thank you.
Good question. Yeah, COVID's impacted everybody, hasn't it? Fortunately, at EastPoint, we had the ability to work remotely already to, get through snow days and things like that. So the transition to working remotely for us was quite straightforward and pretty seamless. In terms of how it's impacted our work, as far as scanning goes, we only need one guy to scan. So with some, safety forms to illustrate that our scanning specialist hadn't been ill recently and hadn't been in contact with anyone with COVID and that kind of thing, he was able to continue his work, and my modeling specialist was able to continue his work remotely. So quite fortunate that this project has really not received any impacts to the schedule.
Perfect. Good.
I hope that answers your question.
Yeah, thank you so much. And so how big is your team at EastPoint? You mentioned two, how many people was working on this project?
So right now it's just been the three of us working on this.
Three of you, yeah.
Project. Yeah, but I have a team of eight BIM modelers.
Oh, perfect. Okay, so that's quite good. Yeah, thank you.
You're welcome.
Quite a large team, 8 people, 8 modelers.
It is, yeah. We put a lot of work out. We're a busy group, and we enjoy the tools we have for sure.
Mm-hmm. Wonderful. Okay, any final call for questions? Okay, Simon, I'm going to kick you out while I share mine for another moment. Okay, I'm not sure if anyone can see that, but this is where I would normally announce what our talk will be in 2 weeks, which will be Thursday, July 9th. We have a couple of pokers in the fire, but we haven't decided exactly who's going to be speaking for that day yet. So be sure to check our website and our social media channels for the latest updates. And if you know anyone who is interested in speaking, we have a platform for you. So be sure to get in touch, info@gans.ca. Now, if everyone could take themselves off of mute for a moment and give Simon a hand, that would be wonderful. And again, thank you very much, Simon, for your presentation today.
Thank you very much. It was a pleasure.
Thank you. Great. All right, take care, everyone, and we'll see you again in 2 weeks.